So hello everyone. I would like to present the presentation which concerns the research that were carried out at the Central Institute for Labor Protection, and these are our current and past studies, but they have a common purpose that means the building awareness of safe working practices during the additive manufacturing. And I must say that this presentation will concern mainly chemical and particles, that means chemical and aerosol hazards, because I'm a worker, I'm a researcher at the Department of Chemical Aerosol and Biological Hazard at the Institute. So, first of all, additive manufacturing has almost unlimited opportunities in every field of manufacturing. That means starting from prototyping through different types of application in medical application and pharmaceuticals. We can use it to printing of food or even buildings currently. So there's a lot of possibilities to use this technology and the set of technologies actually. And we must know that apart from those outstanding properties, opportunities and applications, this is still a source of new processes, new kinds of materials, as it is really rapidly growing technology with little hazard and exposure data. That is why we need some kind of holistic approach to risk assessment in additive manufacturing. We need to take into account different parameters. That means not only the process itself that concerns the mechanism and the energy that is applied in additive manufacturing or any supporting processes, or but also the materials that are used. That means the materials that are used as a feedstock, raw materials which we need to concern their toxicity, their safety, and the composition. So one more thing is the environment, because it is not only the working organization, the location of the printer, the ventilation system, which is applied in the place where the things are printed, but this is also the storage and the transportation of those, for example, materials. So the following steps to assess risk in the additive manufacturing tasks, we need to first of all identify the hazards, then we can evaluate the risk, and after it decide on the control measures to be applied. In this technology, we should follow, of course, the stop philosophy, for example, when we start with the control measures, starting from the eliminating the risk if it is possible, but following by those which are really effective, like substitution of the process, substitution of the materials that are used in additive manufacturing, and also the tasks such as technical measures followed by organization of work and the personal protective equipment. The identification of hazard is the most crucial step, of course, in the risk assessment, and of course we should take into account that that the hazards are caused by different types of factors, starting from the physical, like noise, machinery, moving parts, that can be, of course, a hazard in the additive manufacturing, psychosocial, concerning, for example, stress at work, and then the chemicals. I mean chemical substances and their mixtures, and also particles. To start assessing the risk in the additive manufacturing, we need to think about what pollutants are used or emitted during the printing process. What is the risk to human health from exposure to these chemicals, but also what factors influence the type and the scale of these emissions. What chemicals do we mean when we think about the additive manufacturing? These are not only the materials that are used for printing, that not only the raw materials that are used as a feedstock, which are very different depending on the technology which is applied. They might be thermoplastic, polymers, different types of resins, but also metal powders and so on, depending on the technology. But these are also the chemical substances and their mixtures which are used before and after the printing process. So we have different types of activities before printing, and then, for example, when we use different types of solvent for cleaning the printer and so on. So this also should be taken into account. And then the emission, so the thermal decomposition products of both raw materials but also the additives that are used to prepare those filaments. For example, if we talk about the FDM technology, the most popular one, fused deposition modeling. We have performed a first test in our institute that covered the analysis of chemical compounds and also particles at the workplaces where different people used the FDM fused deposition technology. We found that depending on the filaments used during printing, different levels of total volatile organic compounds were emitted, up to 4,000 micrograms per cubic meter at the selected workstation during this type of printing, which covered the compounds that are quietly hazardous for human health, that may be toxic for humans, maybe some of them are also of course resulted from the thermal degradation of the monomers, but also from these additives, as I already said. So it depended on if the chemicals additives covers, for example, dyes, plasticizer, or other compounds to improve their, for example, mechanical properties. Of course, it should be underlined that it also depends on for example, like here it is presented the temperature, because it depends on the parameters of the printer that are used for this kind of technology. Different types of compounds like carcinogens increase the risk estimated at the printer operators' workplaces, and of course require appropriate preventive measures. And also the substances that can be harmful for the skin should be taken into account and enforce thermal risk assessment in this area, because we think about, for example, resins in other technologies, because we tried to measure not only fused deposition modeling. Concerning the emission of particles, it may be of concern due to their negative health effects, of course, and our studies have shown that more than 90% of the particles emitted were at the nanoscale, that means below the 115 nanometers. The average number concentration of the particles emitted during the operation of the printer were measured at the level even up to 60,000 particles per cubic meter, so it is quite high. It is really hard to present all the results that we have obtained during the first study, so if you are more interested in our results, please feel free to see our publications that were prepared in the first phase of this project. And we have also prepared some guidelines for additive manufacture practitioners, starting from the good practices that covered the infographic presented on the slide, which covers the training, ventilation, access of authorized personnel only to this kind of printing, also application of lower emission materials if it is possible, or applying limited working hours for those who carry out the printing activities at work, and also use of personal protective equipments. We have prepared also some recommendations in the form of a brochure. This is in Polish, of course, but we have also prepared some training materials that are used during the training we are carrying out for those who use this FDM technology at work. Our current research were rather prepared also in the same technology, but to measure the emission of both the particles and the chemical compounds that were indeed identified in the previous studies. But we focus on the test chamber analysis. That means we equipped the chamber with a designed air supply system and the system to maintain humidity within the required range. For our tests, we use two types of particle size analysis systems to determine the number concentration, and also chemicals we are analyzing with different types, sampling with different types of filters and sorbents, and then analyze them chromatographically. This research rather are focused on the trying to add some information to the users, which filaments are actually less emissive. That means our preliminary results showed that after 4-hour printing process from the most popular ABS filament, the emission rate of total particle emission was about 7.565 10 to 5 particles. We have also started the toxicological studies because this part of studies is composed of two. That means we work within 3 different groups: the chemical laboratory, but also toxicological one, and the ventilation one. So the toxicological studies. We are starting from using two different types of phthalates that were also identified in the first phase of our project. And we are trying to use the human barrier cell lines and lung cells that will be exposed to the samples collected during the 3D printing, but also to selected commercial substances. And at the first phase, these were dioctyl phthalate and dioctyl terephthalate. Those two differ among each other because the terephthalate is endocrine disruptive agent and DOP is not. So we are trying to see their toxicity, and the in vitro toxicity of phthalate group in a human cells lines was also evaluated. Of course, the alteration in mRNA level for pro-inflammatory markers and endoplasmic reticulum or stress mediators will be examined using real-time PCR reactions in the further studies. So, to conclude, the presented research will contribute to increase the knowledge and understanding of both manufacturers and printer users regarding the exposure to chemical agents and particles at work. Besides, of course, the building awareness of safe work with chemicals prevents many problems for printer operators and reduces the health risk. And this research that are currently presented will contribute also to the safe working with different types of filaments, with different parameters from different types of manufacturers also, by facilitating the users the choice of less emissive materials. So thank you for your attention, and I would also like to acknowledge the authors of those both projects, which is really a big group. So thank you very much.
Thank you.